This is scientific investigation skills related to astronomy. This is a general purpose lesson in logic, not in memorizing a bunch of terms. So while it is a very long slideshow, there's actually very little you have to take away from this. The main thing is I want you to be able to tell me the difference between observation and inference, to be able to discuss the word assumption, conjecture. Fallacy of affirming the consequent is not required to remember, but observation and inference will definitely be quizzed on. The difference between logic and observation is logic is how you think. So here's an example of a set of logical statements and their conclusion. All humans are mortal. I am a human, therefore I am mortal. That is clearly seems to be a very rational statement. But I could make another one just as well. All humans have 2 arms and legs. I am a human, thus I have 2 arms and legs. This is logically valid, but is it necessarily true? Here's an example using observation. I turn on the light switch in the class, and I found one of them would actually make the lights go on and off. And I repeatedly test this. The lights turn on and off with that switch. Here's the key. Can I claim that this is the only switch that controls the light, or that it is a switch that controls the light? Now, what if I find another switch and it seems to do nothing whatsoever? Can I now say this other switch is connected to nothing? Which one of these is harder to prove? That it is the only switch, or that switch does nothing whatsoever? Here's another example of how you can mistake your reasoning. You train a flea to jump on command when you say jump. The researcher tells the flea to jump, and it leaps 30 centimeters in the air. He then pulls its legs off and commands jump repeatedly, and the flea just stays still. His conclusion: fleas with no legs are deaf. And then he's also investigated by the Science Ethics Committee because he never got permission to pull the legs off a flea from his peers. Now, another person does a little bit of theory, and they try to construct a model of how it's possible for more than one switch to control a light. And they come up with this diagram, which is how your stairwell lights at home are wired. So the switch at the top and the bottom of the stairs both control the light. Now, this is really strong proof or a model that demonstrates that you could, in fact, have more than one switch. So now we're beginning to construct models and a theoretical explanation of how the switches we found work. So this is putting us on safer ground now. Here's a classic example in science that in the early days when they were trying to figure out what made people sick. I observed one day that everyone who drank water fell ill with this mystery illness. This seems like a very solid inference. The observation: people are sick. People who were sick drank water. The inference is, so the water is poisonous somehow. But what's wrong with this is it makes the assumption that the only thing that could make them sick was the water. Could it have been something else? Sure, these 3 things also were shared by everyone. And this was Semmelweis, the guy who identified chlorine soap as stopping illness. He didn't just test if his soap made people less sick. He tried about a dozen different changes in the hospital, and he found the only thing that made a difference was his soap. That was what was brilliant about him. He didn't just make one change, see an improvement, and go, therefore I found the cure. He checked everything. If you make the assumption that there's only one thing you noticed and that one thing must be the cause, this is called the fallacy of affirming the consequent, a really stupid name. How can this happen? Very often, we get trapped in correlation versus causation. Correlation means they seem to occur together. Causation implies one is directly causing the other. Your alarm clock rings at sunrise every day. This is a correlation between the two observations. But does the sun actually cause the alarm to ring? How about the reverse? Does your alarm clock make the sun rise? So you can prove that they are correlated. Proving that there is a connection between the two is harder. Here is a very famous fallacy. I heard that if you fall in your dream and you hit the ground, you're going to die. Found Grandma dead in her bed this morning. Therefore, she must have had that fallen dream. This argument is wrong for 3 reasons. 1, there are numerous ways to die in your sleep. This is the fallacy of assuming only falling dreams can kill you in your sleep. 2, the premise is actually completely not true. You don't die falling in a dream. I know, I've hit the ground and lived frequently. I used to mountain climb in my 20s and frequently had anxiety dreams of falling off the cliff. And I hit the ground in my dream and in some cases bounced right back to the top. So it's not true. And scientifically, the most important thing is, how could anyone ever test this? We can't read people's dreams yet. You could equally say, no, I think Grandma drowned in her dream. And I just know someone's going to say, yeah, but the bed's not wet. And then I just want to go. So we're going to look at inference, how we can make reasonable expansions on our observations to what is the cause behind it. So here's one that I didn't like when I read as a kid, some Sherlock Holmes. He observed this watch has scratches around the winding keyhole, back when watches had to be wound with a little key. So he concluded that the owner often tried to wind his watch, but kept missing the keyhole and scratched the watch case. A sober man should be able to do this, but a drunk man would fumble and damage his watch. Therefore, the owner of this watch drank a lot of alcohol. Is this a reasonably solid line of inference, or is it another example of assuming the fallacy of the consequent?